we thanks. Yesterday, we introduced the idea of a quadratic equation. So it has an equal sign. And the idea of solving equations. And when we solve equations, we find the value of the variable. We also call that the solution. Sometimes we call it the root, x-intercept 0. All similar ideas. Okay, what makes an equation an equation? The equal sign. Okay, and so let's just move on with that. So yesterday's tool was factoring. So we would use factoring to solve quadratic equations. Cool. And I told you, guess what? We're going to have a new tool today, the quadratic formula. Not just yet, because I want to finish this pretty question. So we're asked again just to solve a quadratic equation that has fractions. Who likes fractions here? Love them. Who does not like fractions? Yes, we want to get rid of fractions. Can we do it? Yeah. We just need to clear this fraction. So we need to find a common denominator for all these fractions. Now, folks, tell me, this -2, I'm going to rewrite it. What's the denominator of -2? Beautiful, right? So if I have a whole number, I can write it as a fraction over 1. Okay? So now I'm looking for a common denominator for all these fractions. Meaning, what's one number that you can divide by 6, 3, and 1? Anyone know what it is? We could do 6. Okay, so what I want to do is I want to do it so that each fraction has a denominator of 6. So in order to make this denominator 6, what do I need to multiply it by? 1. And so what that means is I'm going to multiply the bottom and the top of the fraction by 1. Now, do I need to do this? No, it's a bit redundant, right? I don't need to do it. The second fraction, if the denominator is 3, how do I get to 3? I multiply it by 2. And so I need to multiply the numerator by 2 as well. How about this third fraction? Yeah, multiply by 6 over 6. Folks, what is 6 over 6 equal to?
1.
What is 2 over 2 equal to?
1.
Right, so if I multiply something by 1, am I changing it? No. So that's why I want to make sure that the numerator and denominator are the same, so that I'm not actually making the value bigger or smaller. Okay, so x squared times 1 is x squared. Minus, I'll add the minus, 4x times 2 is 8x. -2 times 6 is -12. What would happen if I now multiplied each fraction by 6? We would. So if I just said all of this times 6, then I'd say, okay, this fraction times 6, this fraction times 6, this fraction times 6, right? I can do that because I'm multiplying the left side and the right side by 6. And so the numerator and denominator cancel out. So when I cancel, yes, please. Yeah. Do you clear the fractions immediately?
Yeah, so I brought
Yeah.
2 over first, and
Okay.
then multiplied the whole equation by 6.
Yeah.
And then you get like 24 over 3, and then you're getting the same answer.
Yeah, totally. That's absolutely fine. Yeah. All right, we are left with x squared minus 8x equals negative 12. Quincy, why would you bring the negative 2, or in this case, why would you bring the negative 12 over to the other side? You don't know. You got it. Yes, you do know. Because you have to make the right side equal to 0 so that we could use which property? No. The ZPP. The zero property? No, the zero product property. So I have to bring the 12 over. X squared minus 8x plus, right, the 12 becomes positive, equals 0. If I have the left side of the equal sign equaling to 0, the right side equaling to 0, I can use the ZPP. Hooray! The zero product property. And so to use the zero product property, I have to factor. I need two factors. I need to have a product. So I'm finding two numbers that multiply to give me 12, add up to give me negative 8. I'll make my RS table. 12 times 1, 2 times 6, 3 times 4. Which of them will give me 8? It's going to be these ones. Now I have to think about, okay, so I know I put an x in front because this is a simple trinomial. And then I know there's going to be a 2 and a 6. But now I have to think about the minuses and pluses. So if my last number is positive 12, that means 2 times 6 equals positive 12. But I'm seeing a negative here, right? If I try 2 plus 6, that equals to positive 8, not negative 8. What's another way of multiplying two numbers and getting a positive answer? Two negatives. Great. So what if I did negative 2 times negative 6? Does it equal positive 12? What if I add negative 2 plus negative 6? It equals to negative 8. So in that case, we've got negative 2, negative 6. So we have factored, and now we are in a position where we can use the zero product property. So from the first factor, what does x have to equal to make this factor 0? X equals 2. The other factor, x minus 6, well, x would have to be 6, right? Because 6 minus 6 is 0. So the other option is that x equals 6. There. Yeah. All right, and then I make a final statement. I say, therefore, I'm going to use some math words. I'll say the solutions are x equals 2, 6. So it ended up being a simple trinomial factor, but I needed to just clear the fraction. Okay? All right, let's try to apply this to a word problem. Can I ask, who does not like word problems here? Yeah. Now, who has a highlighter here? Take it out. Or another color pencil or something. Anyone need a highlighter? I've got beautiful green ones. Okay, you ready? Great. Lindsay? Victoria? Alexi? Oh. Okay. Oh, that was close. Gabriel, you need one? Okay, anyone else? Alina? Oh, sorry, that was a bad throw. Anyone else? All right. So, when I teach students to read word problems, now I'm going to tell you why I teach this way. I teach this way because I struggled with reading. I was a slow reader. I would say I'm still a relatively slow reader, and it takes me time to process what I'm reading. It actually makes me a better teacher because I can understand, oh yeah, for some students it's also difficult to process. So I've come up with strategies that help me, and I'm going to show them to you, and maybe they're going to help you. And this trusty highlighter is beautiful. I find that when students write a test and highlight questions, it helps them. They don't miss stuff. So let me show you how I might read this question. Okay, can I ask you to stop talking, please? So I'll take pink just because it's beautiful. Okay, so as I'm reading a question, I have two styles of, I might use two different highlighting colors, or if I only have one color, this is my style. Underlining important information. You don't have to write this down. I'm just going to show you. And I circle what I need to find. So I actually have two different highlights, two different colors that I might use. Okay. So I've got my highlighter, right? So a straight line is just important stuff. Circle is, this is what I need to actually solve for or find. What is the question asking me to do? So let's read the first sentence and just underline or highlight straight what is important. A piece of paper is a rectangle with a length that is 5 millimeters less than the width. What is one important word? Not rectangle? I need to know the shape I'm doing. Okay, rectangle is helpful. Okay, this length is 5 millimeters less than the width. Anyone feeling like a let statement is happening? Oh, yeah. Oh, yeah. All right. The area of the paper is 9,450 millimeters squared. Important? Yeah. So everyone's going to highlight different words. Determine. What does determine mean? What's another word for determine? Figure out, find, determine the dimensions of the piece of paper. What am I looking to solve for? The dimensions. And what are dimensions? The measurements. So I'm basically saying I'm looking for length, width. Okay. I am also, in addition to the type of learner I am also a visual learner. So I will often say, draw a picture. What is our piece of paper going to look like? Well, it's a rectangle. Do not draw a square. Come on. Come on. The length is 5 millimeters less than the width. Which variable do you want to use? We could do L, but we actually just need one variable. So we could do LW, but we just need one. Yeah.
The width, we do L equals
Yeah.
W minus 5.
Good. Let W represent or rep width and W minus 5 rep length. Now, how did I get to that? Sorry, I'll slow down. On my picture, I'm like, okay, they're not saying anything about the width, so I'll make the width just the width. Now they say the length with a length that is 5 millimeters less than the width. So length is here, but the length is the width minus 5, less than the width. On my picture, I'm also going to put this information. Right? That sort of, this picture actually describes the whole question, pretty much. And so there's a reason why we are working on this question in a solving quadratics by factoring lesson. So we know that area equals length times width. What is the area? Well, the area is 9,450. What is the length? W minus 5. What is the width? Just a W. You will have some of these questions for homework, and it's going to be a shape question, right? And for the test, I'll tell you, you need to know a shape question. I'll always give you a formula. Like if it's for a triangle, I'll write down the formula so that you don't forget that. Okay. What can I do on the right side? What's the proper math word? Distribute or expand. Meaning I go W times W, W times minus 5. Right, so W times W, W squared, minus 5W. 9450. What do you think I want to do with that 9450? I want to bring it over to the other side because how do I want my equation to look? Show me with your hand, what do I want on one side of the equation? A big 0. That's right. So let's bring that over. I'm left with a 0. And the 9,000 becomes negative. Oh boy, folks. I want to get to the ZPP. So I must factor. Okay, this is a bit tricky. In order to factor, I'm looking for two numbers that multiply to 9450 and add up to 5. Whew. We're not going to do the whole list. I might just take a guess. Like my sense is like, I want to see if 9450 gets divided by 50. All right, let's just see. So I would take my calculator and I'd go like 9450 divided by 50. Yeah, it can divide by 50. So 50 times 189. Does that give me a 5? No. I need a bigger number. So let's see what other multiples we can find, right? I know that it's going to be 10 times 945, but that's even worse. 9450 divided by 85? No. It goes by 90? 9450 divided by 90. Okay, that's helpful. So 90 times 105 still doesn't give us our minus 5. 9450 divided by 95? Nope. No. finding anything? No, I feel like there's a typo. You know what we're gonna do? We're gonna make this middle number of 15. Is that? Because otherwise, I don't know how to make it work. So if these are my numbers, okay, I see it's a simple trinomial because I have a w squared. I'm going to have a 90 and a 105. Are both negative? Are both positive? Is there one of each? See how the 9450 is negative? So we need to have one of each. Now, which one is negative? So you look at the middle term. What is the middle term? Negative. So the bigger number becomes negative. The smaller number becomes positive. What are we doing here? Well, we can now use the ZPP. We can say, okay, from the first factor, we can say that W would be equal to negative 90. And the second factor, W would be equal to 105. What am I talking about? What is this question about? What is W? Right? I'm trying to connect to what I'm actually doing. What is W? The width. So use your critical thinking. Point to the one that just doesn't make sense. Which one does not make sense? Minus 90. Why, Alex?
Because the width must be like larger or larger.
Yeah, it has to be larger than 0. It has to be a positive number. So we cross out. And that means the width is 105, right? And then we can find the length. Now 105 what? What units? Millimeters. Okay, I'm not going to find the length because there's a mistake in this question, right? Because it should be 15 less. But we see how we can take a word problem, draw the shape, declare the variables, and then actually solve it with factoring. Okay. So that's going to be the end of 5.2.